Our aim in this video is to compute the following sum. We don't want to use any criterions because we want to just practice to see if we understand the sum of the series. What do we mean by that? The partial sums and the limit. And how can we see if this one is convergent or divergent based on simple algebra? In fact, so let's assume that this one is has some sum that we call S. This sum is defined by the limit as n goes to infinity of Sn. And what's Sn? It's the sum of the k going from 2 to infinity, which is defined another way, the limit as n goes to infinity of the sum of k going from 2 to n of ak. In fact, this is what we mean by Sn. So Sn, the partial sum, is the sum of ak, the first n terms of our series. Okay? So we add these ones. We add this one, which in fact is a2 plus a3 up to an. In our case, we are starting from 2 because when k is 1, we have a problem. Okay? Sometimes we can start from 0, we have no problem. But we are talking about this case. Okay? So the Sn is the sum of the terms. Okay? In our case, ak is just 1 over 1 minus k squared. Okay? Sometimes it's very helpful to decompose this one. And in our case, we're going to decompose this one in some fractions. So let me do it here. So 1 over 1 minus k squared. Think of it as 1 over 1 minus x squared. So this one, because 1 over 1 minus k squared can be written as 1 over 1 minus k times 1 plus k. So as 1 minus x times 1 plus x. So in this case, we can write this one in this form. 1 minus k, a over 1 minus k plus b over 1 plus k. We can find this a and b and make it easier to compute here. So in fact, if we do multiplication, we get a minus b times k plus a plus b over 1 minus k squared. And here we do identification. There is no term here that has k, so that means a minus b is 0. And the only term that has 1 is this constant coefficient, a plus b. So that means a plus b is 1. And a minus b is 0. If we add these two, we get 2a equals 1. That means a is 1/2. And the same thing from here, we get b is a. That means b is 1/2 as well. So therefore, we have 1 over 1 minus k squared can be written as 1/2. I'll take it outside. 1 over 1 plus k plus 1 over 1 minus k. Okay? So this is my term ak. Okay? So I can rewrite it another way. 1/2 1 over k plus 1 minus 1 over k minus 1. I just factored here by minus and I put it here to make it easier to compute. Okay? We're going to make this one what we call a telescopic sum. Terms cancel. Okay? So given that this our k, it's a new form. Okay? So the sum, let's compute the partial sum. So Sn is the sum of ak, k going from 2 to n, which is 1/2, and the sum is 1 over k plus 1, k from 2 to n, minus 1 over k minus 1. Okay? Let's start computing here. In fact, let's rewrite this one. So the first term here is in this series. Let's focus on this one. We're going to write this one first, and we're going to subtract it from this one. Let's focus on this one. 1k is 1, is 2 is we have 1/3. 1k is 3, we have 1/4. And the last term is 1 over 1n, which gives us 1 over n plus 1. Now let's move to this one. 1k is 2, we have 1. Okay, 1k is, we still have this minus. 1k is 3, we have minus 1/2. Because here we have 1 over 3 minus 1, which is 2. 1k is 4, we have 1/3. 1k is 5, we have 1/4. Okay, and the last term is n, we have minus 1 over n minus 1. We start to see something, okay, but we need to do one more step. 1/2, 1/3 plus 1/4. Here I'm gonna stop at the term n minus 1. What's the next one? 1 over n. What's the next one? N plus 1. And I do subtract it from 1 minus 1/2 minus 1/3 minus the last one, which is n minus 1. Okay, here I can see something. I start to see something. Look, from here to here, and from here to the end of this one. What do I have? I have this minus. This one is gonna cancel. All this one is gonna go. What's gonna be left? 1/2, 1 over n plus 1 over n plus 1 minus 1 minus 1 over 2 is minus 3 over 2. Now, since this is my Sn, okay, now this is my Sn, it's this one here. If I take the limit as n goes to infinity, I will obtain this one here. I'll go back to this definition. Okay, so let me do the limit. Okay, so the limit, think of this one as sequences now. What's this one here? When n goes to infinity, 0. This one is 0 as well. So what's left? Minus 3 over 2 times 1/2, which is minus 3 over 4. Okay, therefore here my sum is minus 3 over 4. Okay, so we tried to do it step-by-step approach, and we computed the sum, okay, without saying if this one is convergent or divergent. We just used our definition of the partial sums of the series, and we used some fraction decomposition to get this result, and we had to see what we can cancel to get this result here. Okay, this proves our results and ends our video.